In this video, we're going to talk about when to break the rules of creating four-sided patches. Hey everyone, this is Matt with Learn Everything About Design, and in this video we're going to carry on with our Subaru WRX, and we're going to focus on a smaller area and how we can change the patch layout in order to fix a few problems. Now, if you've been following along and you've been looking closely over the car, there are several areas where we have problem surfaces that pop up. In this model that you'll find in the description, I've fixed a few of them, but I've left a few areas that I wanted to talk about. I'm going to use my Control or Command 4 to get rid of some edges, and then I want to talk about a couple of different places. Right here, we've got a small section where we've got a little bump in the surface, and this is an area where we really want to control the crease. And then if you look at the fender flare here, you can see that we've got a problem here where we see some surface tension. I'm not really sure what the best term for this is, but it's when we have multiple patches competing for the surfaces that are getting created, and we really need to take a look at the patch layout underneath and maybe change the way that it's working. So I'm going to bring back those edges, and I'm going to start with this area down here. Now, first, I want to note that we have, from the beginning, talked about four-sided patches, and there have been a few times where we've broken that rule and we've created a three-sided patch, but in general, a four-sided patch is going to work much better. In this patch right here, you can see that we've got two T-points. Now, this is where we've got an edge that intersects in the middle of another edge. So to get started, first I want to go to Utilities and Repair Body. And I want to note that both of these are listed as star points right now. You can see the yellow T here, the yellow star here, and both of these are star points. If I click on these open points, it'll turn them into T points. And as we look at the rest of the geometry, if we try to convert both of them to T points, then we've got a problem because now they're both competing for that same geometry. And this is obviously a problem. So I'm going to change the upper one to a star point and take a look at the results. That looks pretty good. I'm going to reconvert that to a T point and convert the bottom one to a star point. And this looks okay, but you'll notice that we're getting that issue with the surface down here again. So I'm going to leave the upper one a star point and the lower one a T point. And this gives me a much better transition, and the quality of that surface is a lot better. So this is a good result here. I'm going to say okay, and I'm happy with the way that that looks. It fixed the issue that I was having along this crease, and everything looks pretty good. Now you might be wondering why we would even bother having these T-points here. Why wouldn't we just connect them and make this a three-sided patch? Well, if we come into Modify and Insert Point, and we try to do that, oftentimes what we'll end up doing is we'll be shifting the tension of that face, and we'll just simply be moving it down the line. You can see here, if we rotate this around, it might be kind of hard to see. You might want to zoom in and zoom out, rotate around. You can see there's a point right in the middle of that surface. This could just be a graphics thing, but really what's happening is this edge is forcing an issue in the surface, and really it's because of this transition. It's this lower patch here that happens right in this transition is causing that tension there. So I'm going to use Control Z to undo, and you can see that when we have this as a five-sided patch, it works a lot better. So again, three-sided and five-sided patches are not ideal, but in some cases, it's just a necessary evil. It's something that we have to do because we really need to be able to control the transition of these faces as they go around. We want to create what's considered a loop. And if we go into our Edit Form tool and we talk about our selection options, this isn't something that I've even talked about yet, but inside of the selection options, you can see that we've got a lot of different ways that we can select. We've got grow shrink, we've got loop grow shrink, we've got ring, now we've got select next and feature selection and so on. These are extremely handy, especially if you are looking at, let's say, a thin section on a generative design form body. The feature selection can be extremely handy to help use tools like Cylindrify or Smooth. For us, if I select a single edge here, for example, and I grow the selection, it's moving out from that edge and it's selecting everything it touches. If I continue to grow, you can see that it's growing more and more. And if I come back and shrink back down, I have my single. If I select a face and I grow or shrink, you can see that it's grabbing every face it touches, and we move around. If I were to try to do this with the loop, if I select this edge here and I try the loop grow shrink, you can see that it's pushing that edge around. It's creating a loop around the geometry. Now, with this case, that loop actually ends at the grill opening. And in a lot of cases, the grill openings and the headlight openings and features like this, those would generally happen after we convert the form. We would generally create those with standard tools like a split body or an extrude or a trim, and not generally do that kind of thing in the form tool set. Now, if you're using some other subdivided modeler, something like Blender or 3D Studio or Alias or Cinema 4D or something else, then you would likely use it to create these features. But in Fusion, the surface quality is much better if we jump out and we use the surface tools, like creating a sketch and simply extruding it or trimming the surface away. We're creating these openings in the form body because it's a good challenge. It's something that you can play around with. You can find out where those limitations are and where those challenges are. For example, on this body, since the last time you guys saw it in the last video, I actually went in and I creased these two edges, the leading edges on the headlight bezel. The continuous curvature there in that area was really causing a lot of problems, so I wanted to get rid of it. But now that we've talked a little bit about growing and shrinking, and I also want to note that the display mode is listed in here in the selection options. Now that we've talked about that a little bit, let's talk about fixing this edge here. So again, Controller Command 4 on the keyboard, you can see that that surface it's got problems right in the middle, and then this edge or this transition is causing issues. So I'm going to go back to my box display mode, which is Alt and the number 1. If you guys are on a Mac, I believe it's Option. And I want to just take a look at the patch layout. So you can see it's a little bit wider back here. It gets a little bit narrower here. And then this carries into a lot of edges. We have this sort of combination of all of these in order to get that transition. If I go back to my smooth display mode, you can see this area is kind of a mess. We've got these creases that are coming in, and this is just not a good scenario that we want to be in. So the first thing that I'm going to do is I'm going to try Make Uniform. And when I use Make Uniform, if we have any star points where the edges are competing, a lot of times that'll help fix those. It didn't really do much for this area, so let's try Repair Body. And you can see that we've got a T-point up front, that's fine, and then we've got a couple star points. Also note that this is the Weld Tolerance. The Weld Tolerance right now I've got set to 0.01. This is something that really only applies if we're auto repairing free edges. So that Weld Tolerance, it's kind of annoying that it always pops up where I want the cursor to be, but just note that that's what that value is. It's a Weld Tolerance that has to do with free edges and combining free edges. So I'm going to click on this star point, and you can see that it was able to sort of readjust. It gave us a little bit better combination of those edges up front. It's a lot smoother, so I'm pretty happy with that. And let's try this star point here and see what happens. Nothing happens. It wasn't able to do anything with this one here. So this is something that we're going to have to manually work on. So at this point, I'm going to say OK, and then I'm going to see how I can fix this. So I'm going to start by selecting that vertex, going to Modify, and from the front, I'm going to zoom in, and I'm going to pull this to be more in line with the one behind it. So I want to come up and sort of stretch it out a little bit. And before I change anything else, I'm going to go to my right-hand view. I'm going to find that same vertex, and I'm going to bring it up a little bit in this view and a little bit forward. I'm going to go back to Smooth Display, Control or Command 4, and I want to take a look at the result. So far, it looks a lot better. The transition looks better. We still see there's a little bit of tension in the surface. We've got some competing edges, but it looks a whole lot better than it did at the start. So how can we continue to work on this? How can we continue to fix this? Well, we've got these triangular patches here. And these triangular patches we already know are generally not a good idea. So I'm going to try to delete this one and see what happens. So if I hit delete, and I'm actually going to delete this one up here as well, go back to my smooth display, we can see that now that surface patch looks a whole lot better. The crease on this edge is probably a little too tight, but the one that's leading into this triangular section looks a whole lot better. We've got a much better scenario there. I'm really happy with the way that looks. Now we want to take care of the rest of that transition. So I'm going to bring those edges back, go back to box display mode. And in order to fix the rest of these transitions, you'll notice that if we view this from the front, that we really have a near vertical edge here. So these edges are near vertical, and I'm going to pull them in a little bit. I'm going to space this gap out. I'm going to pull that in. I'm going to pull this one in a little bit. And then I need to find the next one in the chain. So if I rotate this around, it's this one here. It's going to be hard to see from the front, but I still want to move it around and see if I can just pull it in, rotate this slightly, and then go back to my smooth display mode. So in smooth display, this is really going to help us better identify what's happening in those edges. So it's still a nice, clean, crisp edge, and that looks pretty good in terms of the transition. I'm happy with the way that that looks. Now, I should note that this is, and I know I've said it before, that this is a fairly complex model to do something like this with. In general, when you were, thinking about modeling something like this, like a car, the door section or the midsection generally will be fairly consistent. So when we talk about fairly consistent, it would be something that is likely a single profile that has a slight curve to it. And I'm talking about in the Z direction, it'll have a curve, but also in the Y direction, going from front to back on the car. And you'll carry that curve back. When we're doing this as a form body with these subdivided sections, we have a lot of detail that happens around these fenders. And that's not true for every car, but it is true for this car. We have creases, we have fender flares, we have transitions of the bumper that come in to the wheel well. And all of these transitions cause us to increase the number of edges and vertices that we have to control that curvature. But as we get to areas like the door, we don't want all of that extra control because it just makes it more complicated. And the way that this model has worked out, I'm pretty happy with it. There's still a lot of areas that could use a lot of attention. Like, for example, the hood scoop area does not really replicate what it does on the real car. There's some things to consider here. For example, the hood scoop on the real car is not actually a smooth transition with the rest of the hood. It's something that bolts on. So the transitions or the curvature continuous transitions are not a realistic approach. Same thing with the spoiler. The spoiler was extruded up and there are some creases, but it is a nice smooth transition. And in reality, that wing or that spoiler is bolted onto the car. So there are some areas that are modeled like this for appearance and effect that aren't sort of a reality. This is not really the way that you would model some of the stuff. But it does get us pretty close. The car looks pretty good at this point. If we take our edges off, again, Control or Command 4, the flares look pretty good. They terminate into the door. The door looks pretty good. The front end that we started off looks pretty good. And again, there are some areas that we could work on. But overall, I'm really happy with the way that the car is turning out. If you've kept up with the process this far, then I applaud your effort because this car itself, again, it's very complex, and that's really why I keep coming back to it and just addressing small areas rather than continuing to model the whole thing. If you guys are following along with the series and you want to see a car modeled from start to finish, I can probably find a more simple example, something that doesn't have a lot of these hard, sharp, creased edges and all of the detail that the Subaru does. But if you want to see that, please let me know. I'm happy to, attempt another car body, get us a little bit closer. This one, as I mentioned, is far from done. There are side skirts. There's additional features on the front bumper. And there's also a detail in the middle of the door. These are all areas that I think would be great practice and something that you should definitely try. But at this point, I know I've said this before, but I'm not sure how much more I'm going to do with this car. I think I have approached the basics of modeling something like this. Starting with the hood, we learned about creating a face and extruding the edges and transitioning around. Then we talked about some more complex topics. We carried on and we merged two form bodies together. We did a cylinder for the wheel arch, and then we sort of merged that with the rest of the fender, and we learned how to build the patches and how to delete edges ultimately and go back to a more simple version. So at this point, we've taken care of some of the basics of modeling, and we've also taken care of fixing some of the problems that are going to arise if you continue to work on this car. So now we know about some of the utilities like repairing the body and what it means to have star points and what it means to have T points and what those really do to our model. You can see here that we've got a star point here. If we click on it and allow it to fix it, that looks like a much better result now, allowing it to fix it. So the utility works. And again, sometimes the utility is there as sort of a something that we use for potentially bad modeling practices, potentially workarounds. You can see that that star point, fixing that actually caused a problem down here. If we use Control Z and undo, then that looks pretty good. So even though it was able to fix that star point, it caused more trouble down in some other surfaces. So these are areas that we would either need to manually fix or work on, or just be okay with the results. If you were going to model a car or something like this for production, then Fusion is not really the tool. So this is a great experiment. This is a great thing to play around with, to model these cars and learn the tools. And ultimately, you could use this for production of consumer products. I've made a lot of things in forms that have been 3D printed. So there is a lot of functionality there that you can use. But if your goal is to model cars for anything other than visualization, like creating renders and playing around with, potentially modifying them and making them customized, making them your own, then there are other tools that are much more akin to doing that type of work. Again, it's not something that is necessarily impossible to do in Fusion, just the surfacing tools and the form tools are not really geared towards automotive design. There are specific tools, things like Alias Auto. There are also other tools that Autodesk has in addition to Alias Auto, like Maya. There's 3D Studio for visualization. And of course, there are other companies out there. Blender is a great option that's free, and it's something that I use for something very similar. So here's a project that I've been working on, a car model. And if we take a look at the patch layout, you can see that the patch layout is much more simplified than what we have in Fusion. And this is because these purple edges, I can actually control the edge weight of. So if I select an edge, in this case, I've got a 50% crease. That 50% crease is going to equate to, us having to put multiple edges together in Fusion to get that same effect. And when we take a look at something like this in Blender, we have an underlying mesh, and that underlying mesh is actually a low poly mesh. We can change the mesh display in the viewport, and we can also change it when we render it. So if we take it all the way down and we take a look at it in a very low poly state, this is what it is when we're modeling it, the number of polygons that we have that we're working with. You can see that it doesn't capture the same level of detail, but we can increase that for visualization purposes, and we can also increase it for rendering purposes. So it gives us the option to work on sort of those low polygon models. You can see again with the hood, I've got these purple edges that allow me to dictate the crease, but it allows me to work on those low, consistent patch, low polygon models. And then we can use the options for rendering and shading to increase that by basically adding what they consider a modifier and subdividing that surface. For us to do that in Fusion, it's a bit problematic. So for example, if we took this entire model and we took the entire body and we went in and modified and subdivided it, what we're doing is we're taking all of the patches and we're breaking them each up into 4 additional patches. So the simple insertion mode is going to allow us to do that, and it will make some changes to the curvature. If we use exact, then it's going to keep the shape that we have, and it's going to add as many different selections that it needs to in order to achieve that same shape. So this can get out of hand really quick because we do have that deeper level of subdivision, but the deeper level of subdivision now means that any problems that we had with the original layout are now going to be exponentially worse. And it also means that the level of control in order to change the shape of what we're doing is going to be much more difficult. You can see all the blue selected faces. These were original faces. Well, they're gone now, but those were original faces that I selected before I subdivided. So this looks pretty good for visualization purposes. And if we get rid of the edges, everything still looks pretty good and clean. But again, if there were any problem areas, like here at the fender where we had that sort of error star, you can see that it could potentially add more issues. And if we take a look at this, you can see just how many subdivisions were added in that area. And if we try to go to a box display, even in a box display, it looks pretty smooth. And there are quite a number of patches. You can see there's T-points that have been added. There's all sorts of stuff that's going on. And it's not going to be very easy for us to control. So again, there are tools like Blender, which is free, and there are other tools like Cinema 4D and 3D Studio, Maya, other tools that are really meant for this type of modeling. And if you are looking to do it for production, then that's a whole nother ballgame, right? That gets into tools like Alias Auto, and these are many thousands of dollars to purchase. So there's a very different approach to how we would model something for production versus how we would model something for visualization. And in this case, Fusion is going to be for visualization. You can get something that looks really good and looks really close, but it's not going to be a production level tool. For this one, however, let's go ahead and finish the form. I'm going to show the body. I'm going to go into my render workspace, and I'm going to take a look at it in here and just see if any problems have popped up when we converted it. I'm going to change it to blue. And you can see, even though it looked pretty good, we still have an issue on the door. And the door issue, there's a slight crease there. It's right on an edge between patches. And that, of course, is going to cause a problem. You don't notice it everywhere, and that's actually pretty close to where the door seam would be. So there are things that we can do with surfacing tools that would fix that. But again, it's sort of the differences between something that is a parametric CAD modeler that has the sub-D type modeling versus something that is extremely purpose-built for modeling this type of stuff. And the Fusion tools just don't have all of the options and control that we would want to see to make a production car body. So hopefully you've been able to follow along. Hopefully you've learned a few things, different approach to the way we might use the form tools. I do plan on going to sort of an in-between. I did an introduction to Fusion Forms in one video, and then this one really sort of went a little bit more advanced than I was anticipating originally. So I plan to do a little bit of an in-between, something that's a little bit easier to follow along and maybe a little bit, a little bit shorter in terms of the length and a little bit easier to use as a first project. But again, if you followed along this far and you've managed to make any progress at all, whether or not it's ideal, whether or not it has problems, then I do commend you. It's not easy. There's an artistic aspect to this, and it's not the same as drawing a sketch and simply creating an extrude. It takes a lot of work to be able to look at and add the details that are needed for something like this. So I strongly urge you to keep at it. If you have any questions, please let me know. I do believe that this will be the last video for this car body, but I would love to hear experiences, if you had any problems, if you had any issues along the way, and maybe I can make some follow-ups if I add any more details to this car. But for now, that's it. Thanks for watching. I appreciate it. And if you have any questions, please let me know. But other than that, thanks again, and I'll see you in the next one.